Alright, so let's do question 1 from the AP Calculus AB exam from, let's see, 1988. So the question asks, what is dy dx if y equals x squared times e to the x? So this is an implicit differentiation question. Can never pronounce that right. Alright, so let's differentiate this. So we're differentiating with respect to x. So if we have a y term, as we do here, we have to tack on a dy dx after we derive it. Alright? So what's the derivative of y? Well, it's just 1. But remember, as I said, we have to tack on this dy dx. And now, this is product rule over here, so let's do that in a different color. So the derivative of x squared, let's do the left side first, keep the right side, and then add the left side, and then take the derivative of the right side. So the derivative of x squared is 2 to the x. We keep the e to the x. And now we derive the right side, we keep the left side, x squared. And then the derivative of e to the x is just the same thing, it's just e to the x. So now we're all set. So our final answer comes down to dy dx is equal to, well, let's factor out, we can factor out a e to the x, and an x. So we can factor out a x times e to the x out of both sides, so it'll become 2 plus x. And that right there is the answer. Alright, question number 2. It asks, find the domain of f of x equals x squared minus 4 square root of that over x minus 3. So we have to remember that the domain is where the function is continuous and real. So like if we have a number such as 1 over 0, this is indeterminate form. Indeterminate form. Which means that it's undefined, so it's not part of the domain. So let's take this domain. So when the denominator is 0, it's undefined. It's indeterminate. Actually, indeterminate form is 0 is 0, but this is undefined nevertheless. So we want to know when x minus 3 is equal to 0, and then add 3 on both sides, yada yada. So this is when x equals 3. So the domain does not include x equals 3. The domain does not include x equals 3. Now, for the top, we all know that in a square root, let's say we have square root of negative 1, this is I, imaginary. And in calc, imaginary is not part of our domain. So we need to see where square root of x squared minus 4 is greater than or equal to 0. Because we cannot have imaginaries. But how do we do this? Well, this is pretty simple. No, not this. This is pretty simple. Because we only look at the inside part. So we see x squared minus 4 is greater than or equal to 0. Since if this is negative, then the square root is negative, which makes it imaginary. Understand? So we can't have that. So we can factor this into x plus 2. X minus 2 is greater than or equal to 0. Then our critical points, so our points where we want to find our function values, is x equals 2 and negative 2. So now we just draw a number line. Let me draw that in aqua. Draw a number line with our spots at 2 and negative 2. So let's pick a number between negative 2 and 2. Let's say 0. Now at x equals 0, negative 4. It will be negative 4, which is not greater than 0. No good. So let's pick something greater than 2. Let's say 3. Let's pick 3. 3 squared is 9. 9 minus 4 is 5. 5 is greater than 0. So it's part of our domain. Last one, let's pick a number less than negative 2. Let's say negative 3. Negative 3 squared is 9. 9 minus 4 is 5, which is greater than 0. So this works as well. So this is also part of our domain. Now a lot of students will be fooled, because they're gonna probably do some quadratic stuff like x squared minus 4 is greater than or equal to 0, x squared is greater than or equal to 4, x is greater than or equal to 2, but then they're completely missing out on this part, less than 2. So the domain of the function would be x is part of the real numbers. Wait, that's not how you write it. Is a part of the real numbers such that x is greater than 2, x is less than or equal to negative 2, and x does not equal 3. So that would be our answer. Just reiterating, x cannot equal 3 because that will make it undefined, and x has to be greater than or equal to 2 because if you have a negative under the radical, it becomes imaginary. This should be bubbled in, I'm sorry, because we have a greater than or equal to sign, so it should be bubbled in. And then, yeah, that's the answer, and x is part of the real numbers because we have no imaginaries. Alright, question number 3. A particle moving at any time is given by v of t is equal to e of t, and v of t is just simply the velocity of the function. How far does the particle move from time equals 0 to time equals 2? So if you want to know the total amount of movement of the particle between this, we have to set up an integral, a definite integral from 0 to 2 of our function v of t dt, and then this will be equal to integral from 0 to 2. And what's v of t? V of t is just e to the t, and then dt. And now remember the only function in the world, recall that the dx, or the derivative of e to the x, is just e to the x because it's an identity, it's Euler's number, or Euler, I don't know how you pronounce it. So the antiderivative of this would just be the same thing, it would be e to the t, and we're evaluating this at from 0 to 2, so this would be equal to, we do this one and we subtract it by this one, so we do e squared minus e to the 0th. We're just replacing t with 2 and t with 0. So anything to the 0th power is 1. So this would simply be equal to e squared minus 1, which is the total time that it moves. Alright, question number 4. The graph of y equals negative 5 or x minus 2 is concave down when... Actually, let's check that I wrote the question right. Yes. Wait, what? Is it? Okay, yeah. So it's concave down when... So concave down, this is representing... What is this representing? This is representing the second derivative. Because remember, concavity is a second derivative. If you have something that is, let's say, concave up, it has a happy face, so it's like that. But if you have something concave down, then you have it like that, sad face. So this would be up, and this would be down. So to find when it's concave down, we obviously have to take the second derivative, so let's do that. So the first derivative, actually I don't want to use the quotient rule because I really hate it, to be honest. To be frank, it actually just takes a long time just to do it. So I'm just going to rewrite this as y equals negative, no, not y prime, sorry. Y equals negative 5 times x minus 2 to the negative first. Since if you do just to the negative first power, it's just over the denominator, which is the same thing. You know, this is the same thing as over. So what do we have here? Let's take the derivative. Y prime. So we have to bring the exponent down and then subtract from 1. So negative 5 times negative 1 is just 5. And then We subtract 1 from negative 1, it becomes negative 2, times the derivative of the inside, but the derivative of x minus 2 is just 1, so we don't need that. And now we do y double prime is equal to, again, we bring it down. Let's do it in a different color, shall we? Bring it down, and then you subtract 1. So 5 times negative 2 is negative 10, x minus 2, and then you subtract 1, becomes negative third power, and we can rewrite this neatly as negative 10 over x minus 2 cubed equals f double prime x. Yep. Okay, now to find the critical points, we set this equal to 0. So we set negative 10 over x minus 2 cubed equal to 0. So when is it equal to 0? Well, if this is undefined, then this is a critical point. Remember, critical points are when it's equal to 0 or undefined. But in this case, we have no general way of seeing if it's equal to 0. So we just set the denominator equal to 0. Remember from our first example, that's when it is undefined. So we said x minus 2 cubed is equal to 0. So we will find that x minus 2, x minus 2 is equal to 0 if you cube root both sides. So x equals 2. Now, let's draw our handy dandy number line with x equals 2 as a critical point. Alright? Be aware that this is a circle now. I mean an open circle, not a filled in circle, because we're not looking for the absolute value anymore where it can be equal to 0. If it is 0, it's not concave down. If it's negative, it's concave down. Concave down refers to negative sign. Alright? So let's pick a number such as 3, plug this into our second derivative, negative 10 over 3 minus 2. What's 3 minus 2? 3 minus 2 is 1. 1 cubed is just 1, so this becomes negative 10, which is negative. So this works. And now let's pick a number like 0, which is less than 2. So 0 minus 2 is negative 2. Negative 2 cubed is negative 8. Negative 10 over negative 8 is, in simplest terms, 5/4, which is positive, so this is no good. So then it would simply just be anything that is greater than 2. So our solution set would be concave down when x is greater than 2. And that's our answer.